Hi, have you ever wondered why do atoms come closer? Have you ever thought why atoms combine? Have you ever thought that why ice being solid have less density than water being liquid? All these type of questions we should start a basic question. What is a chemical bond? Let's understand the chemical bond. A force of attraction. Chemical bond is what is chemical bond? A chemical bond is a type of force of attraction between two or more than two atoms to hold them together. It's called chemical bond. And and you know that when atoms get closer to form chemical bond, there is a decrement in total energy of system. To understand this, let's take the example of formation of H2 molecule. It is as simple. Start the example of S2. In example of S2, here you can see that uh, two atoms of hydrogen come closer. There is a decrement in energy by graph. Here graph two axis. One first axis. This axis represents the potential energy of atoms, and this axis represents the internuclear distance. Internuclear distance by means you know that atom contains a nucleus which contains proton and neutron, and electrons revolves around that. A simple model of atom. Here is hydrogen, and in hydrogen atom, if I show you, if this is nucleus, if this is nucleus and this is nucleus, then distance between these two nucleus is internuclear distance, and this axis represents the internuclear distance. When two atoms come closer, when two hydrogen atoms approach each other, there is a net resultant attraction force, and due to attraction, the potential energy of whole system will decrease, and decreasing at particular time it will attain a minimum value. It will attain a minimum value where bond formation between H and H atom takes place and become S2 molecule, and their potential energy will become minimum. At that point bond formation will take place, and after that the maximum stability which atoms can achieve is where internuclear distance are at a position where we call this bond length. That internuclear distance will be referred to as bond length. Now, tendency to acquire minimum energy. What is this? Uh, Chemistry of atoms works on some basic rules, and we call tendency to acquire minimum energy. In chemistry, all the atoms wants to acquire a minimum most stable form, and they do so by decreasing their potential energy and become more stable and stable and stable by decreasing their potential energy. And how this thing happens, I will explain you here. In atoms, when there is a formation of bond, when there must be two atoms which approach each other, come close each other, and what happens in that case? When two atoms approach each other, there is a net attraction between them, and during net attraction, what happens? Let us take a simple, to understand the concept, let's take a simple illustration diagram to understand this approach of atoms, these two approach of atoms. This is atom 1. Let's suppose this is atom 1, and this is atom 2, and this is atom 2. And as you know that in atoms there is a nucleus. In center of atom there is a nucleus, and let's suppose I have considered uni electron and uniproton species. I have considered simple, for the sake of understanding the concept, I have taken the example of hydrogen atom, and there is a one proton, and we denote this by P1, and there is a single electron, we denote this by E1. Atom 1, and we have denoted the electron and proton. Proton is present in nucleus. And here in atom 2, electron E2 and proton P2. Now what happens when two atoms approaches to form bond? There is a when two atoms approach, there is a net attraction in overall system. But what happens during attraction is the electron of atom 1 will get attracted to proton of atom 2, will get attracted to proton of atom 2, and electron of atom 2 will get attracted to proton of atom 1. Okay? And there here attraction works. Is there only attraction which is working here? No, there is some another extra force which also works here, and that is repulsion between these two species. Proton have same charges, and same charges, as we know that same charges repel each other and unlike charges attract each other. Here proton and proton will repel each other, they will repel each other, and electron there will also be repulsion each other. Means there works two force, one repulsion and other attraction. In case of bond formation, attraction is greater than repulsion. And up to which extent attraction is greater than repulsion? When atom come closer, during that process, atom will achieve a state of minimum potential energy, and it is that state where atom is most stable, in most stable form. And in that case, repulsion will become equal to attraction. From there, I will show you these things with the help of a graph. Then it will be more clear. When atoms come closer, there must be a time where repulsion and attraction will be equal. In that case, if I increase single step, if I decrease the distance between internuclear distance between two atoms a single inch, then it will single minute step, then it will start repulsion. They'll start repulsion. Now understand this phenomena of bond formation with this simple graph. What this simple graph illustrate, or from this graph you can extract a simple information, simple conclusion in the case of bond formation. What is happening there? This is the two atoms which are approaching each other during bond formation. Attraction is please remind that from this graph you can remind that here two atoms are approaching each other when attraction is more, and repulsion is less. Attraction is dominating during approaching these two atoms, and it will be dominating up to when till repulsion and attraction becomes equal. And here bond energy, or potential energy becomes will become minimum, and stability becomes maximum. At this point stability becomes maximum. Here after this when we decrease distance, internuclear distance between these two atoms further, then attraction will not dominate. Here repulsion will dominate, and net stability will decrease, and potential energy start increasing. Here you can see that start increasing, and it will approaches to some finite value, but it cannot be possible to make internuclear distance between two atoms exactly zero. Not possible. So here with the graph you can see that at infinite potential energy is considered of two atoms nearly zero. So infinite we consider the potential energy zero, and when they approach, attraction dominates, they come closer, and potential energy start decreasing and attains a minimum value where bond formation takes place. And at that point this internuclear distance is equal to bond length, and this gap is bond energy. This gap is bond energy. That energy which you will give, it will break the bond between two atoms. So you can see that here this graph explains much about the formation of bond between two atoms. From here we can derive a conclusion about the force of attraction and force of repulsion working in this scenario. Let us formulate and tabulate the some results from these discussions. Now this is the result, this is the conclusion what we have discussed earlier about the bond formation with the help of graph and with the help of simple example discussions. Here from the discussion, first conclusion is that potential energy when force of attraction dominates, when two atoms come closer, potential energy start decreasing. But in case of when attraction decreases, when attraction becomes equal to repulsion, then in that case repulsion start increasing and potential energy start increasing. You can remind the graph, you can rewind the video and see that in the graph potential energy starts increasing when force of repulsion dominates, and here in force of attraction stability increases. When potential energy decreases, stability start increasing, and stability is decreasing. The process of attraction of two atoms is exothermic, but here it is endothermic. Okay, and here the attraction happens due to the attraction between proton of first atom with electron of second atom, and proton of second atom with electron of first atom. In here, repulsion, electron with electron of second atom and proton with proton of second atom. So that's